Slope-intercept form. Our objective is to write a linear equation in slope-intercept form, as well as graph a line using slope-intercept form. Who uses this? Consumers can use slope-intercept form to model and calculate costs, such as the cost of renting a moving van. Let's start with some vocabulary. Slope-intercept form. An equation for a linear function in the form y equals mx plus b, where m is the slope and b is the y-intercept. So if you look off to the right, you have y equals mx plus b. Your b is your y-intercept, your m is your slope, your x and your y are an ordered pair from that graph. Your y-intercept is the ordered pair where the graph crosses the y-axis, hence y-intercept. So our y-intercept would be 2 in this case. That's the b value. Let's graph by using slope and y-intercept. So to start, we're going to plot our y-intercept at -2, since that's where the line crosses the y-axis. And now we're going to do our slope. Slope, if you recall, is rise over run. So we're going to rise 3, 1, 2, 3, and then run 4. After you have those 2 points, simply connect them with a line. Let's try this next one. The y-intercept is at 4. So we're going to plot a point on 0, 4. The slope is -2. Think about how you would write -2 as a fraction. Well, you can write any whole number or integer as a fraction by simply putting it over 1. So we're going to go down 2 and to the right 1. You can do this multiple times. So I can go down 2 and to the right 1 again, and down 2 and to the right 1 again. They all are going to fall right on our line. I can also go up 2. But to make sure I have a negative slope, I would have to go to the left 1. And you can simply connect a line. Alright, so slope-intercept form, as you had seen in a previous slide, is y equals mx plus b. M is your slope, b is your y-intercept. So let's practice writing linear equations in slope-intercept form. So we have y equals mx plus b. Our x and y are our coordinates that we would plug in as we're going through, but our slope is m and our y-intercept is b. So in this case, we would have y equals 1/3 x plus 6. Let's try this one. So we have y equals mx. So we need our slope. Our slope is -12. X plus, and what's our b value? -1/2. We can simplify this piece here by just simply having a subtraction sign. So y equals -12x minus 1/2. Take a moment and pause the video and try C and D. Now that you've had a chance to try C and D, let's try them together. So once again, we have y equals mx plus b. Okay, so our slope is 1, so y equals 1x plus 0. We can simplify this to just simply say y equals 1x. If you'd like, you can even drop the coefficient, so y equals x. Either one is acceptable. Alright, so now let's look at D. We have y equals, our m is our slope, so 0x plus our b, which is negative 5. Well, 0 times anything is still 0, so that means 0x is simply 0. So when we simplify, we're left with y equals negative 5. Alright, here's a tricky one. We have a slope of 4, and then we're given this coordinate. Well, if you recall back, you had y equals mx plus b, and the x and the y made up one of the coordinates on that graph. So you can use your x and your y to help you find your y-intercept. So to do so, we're going to plug in the values that we know and keep b as our variable. Our y value to this coordinate is 5. So we have 5 equals, our slope is m, so 4 times 2 plus b. Now we just have to simplify. So 4 times 2 is 8. So we have 8 plus b equals 5. Now we can subtract 8 from both sides, leaving us with negative 3 equals b. Now that we have our b value, we can write this in slope-intercept form. So we have y equals our m, which is 4, so 4x, and then plus negative 3, so minus 3. Now let's try using slope-intercept form to graph. When we do this, we always start with our y-intercept. Then, so that's step 1. Second step is to rise and run your slope. So we're going to start at minus 3, and then we're going to rise and run 4. Well, our slope is 4, so to make this a fraction, it's a whole number, so we can stink it over 1. So we're going to go up 4, 2, 3, 4, and then go over 1. We can do it again, 1, 2, 3, 4, and over 1, and then we connect it with a line. Let's try this one. So we start at our y-intercept, which is 2, and then we rise and run our slope. It's a negative slope, so therefore our line should be going in a downward pattern. So we can go down 2 and to the right 3, or you could have gone up 2 and to the left 3. And then you connect them with a line. Let's look at C. In C, you no longer have this in y equals mx plus b. So it's no longer in slope-intercept form. But we can put this in slope-intercept form. So we have 3x plus 2y equals 8. Our goal is to get this y by itself. So we want to move everything else to the other side. So let's start by subtracting 3x from both sides. We can draw the river to separate our left from our right. So if we subtract 3x, we're just left with 2y. These are not like terms. This one has a variable, this one does not. So they do not go together, they simply go next to each other. So we have a negative 3x plus 8. Now comes the trickiest part. So we want to get y by itself, so we're going to divide the left side by 2, and we're going to divide the right side by 2. This means the 2 goes with the 3 and the 8. It's a binomial, which means it has 2 terms. So when you're dividing the entire right-hand side, the 2 goes with everything. So we have negative 3/2 x, and then 8 divided by 2 would be 4. Well, now we can graph it. So we start at 4, and we're going to go down 3, 1, 2, 3, and to the right 2. We can also go up 3 and to the left 2, and then connect them with a line. Let's try a consumer application. To rent a van, a moving company charges $30 plus 50 cents per mile. The cost as a function of the number of miles driven is shown in the graph. We want to write an equation that represents the cost as a function of the number of miles. So let's start with y equals. Alright, so it's 50 cents per mile, so 0.50 per mile, so 0.5 times x. Now, we're starting with $30 because that's where you start off. So plus 30. Now that we have our equation, let's look at what is the slope and what is the y-intercept. And we're going to describe their meaning. So the slope is 0.5. This is the rate of change of the cost because it's 50 cents per mile. And your y-intercept is your b value, which is 30. And that's the cost if you didn't go anywhere. So if you simply rented the van and left it parked, it would simply be $30. So that would be if you traveled 0 miles. Alright, so now for the last question, find the cost of the van for 150 miles. So we're going to substitute in 150 into our equation for x. So we have y equals 0.5 times 150 plus 30. And when we do that, we get 105. So it's $105 to travel 150 miles. And that ends our lesson on slope-intercept form.